Alright, this is topic 76, slope fields. So this is more common in differential equations, but let's just go through it. So in order for you to do a slope field, all you need to do is go through this coordinate point, whichever ones you want, and then figure out what the slope at that point is. So for example, notice that I have the derivative, so if I plug in a 0 into here, notice that we have 0.00, so that would be that point right here, but notice that the derivative is only relating to x. So if I plug in a 0 back into 2x here, then I get a slope of 0, which is actually a horizontal line, which you're not going to be able to see very well. And then if you go on, if you go 0, 1, which is right here, the slope, again, because I'm plugging the 0 back into this derivative, the slope will also be 0. Okay, so then if I go to 0, -1, which is this point right here, now if I plug in that 0 back into here, the slope is also 0. So the slope really, and all of these that are 0 along the x-axis, because that's where x is equal to 0, all of these are going to have a slope of 0 because on this line x is equal to 0, and if I plug that in back into here, I have the slope is equal to 0 also. Alright, well, what about if x is equal to 1? Well, if x is equal to 1, then the slope is 2. So we're going to put a little line here that represents that slope right here. Obviously, some kind of approximation is not going to be perfect, but we're going to put this line right here. And again, I just happen to pick 1, 0, which is slope of 2. Again, we're getting that slope by plugging in this x back into here. And by the same logic that we used up there, all of these are x is equal to 1. So regardless of what y is equal to, all of these are going to have the same slope. Okay. Now if we go to 2, let's go to 2, 0, that's going to give me a slope of 4. Okay, so we're going to have a slope of 4 here, which is just going to be more steep than the one we had over here, right? Positive 4. And by the same logic again, because x is equal to 2 all along these lines, then I can have the slope of 4 all across those. Alright, and if it's 3, well, if it's 3, then we would have, let's see, 3, 0, we'll plug in a 3 here, that gives a slope of 6. So we have a line that's even more steep than the last. Okay. And I gotta make it a little more steep here than the last one. So that's what we got. And then if we got -1, 0, for example, that's gonna give us a slope of -2. So it's going to be kind of like this slope, but it's going to be negative, so we have a slope that's negative like that. They make it more steep to match the other one. And eventually you're going to find a pattern. Alright, so we're going to find a pattern. And if you go to -2, same logic. So at this point, if you haven't fast forwarded already, you might want to, because I'm going to do exactly the same thing. Okay. Alright, so that's the slope field, and what that's helpful for, alright, so and this is kind of what I talked about, so there is no y in the derivative. Points with the same x coordinate have the same slope. So that's what that's going to be. That's the reason I was able just to go through and fill this vertically. Alright, on the previous graph, sketch the solution curve that goes through 0.01. So if I have a 0.01 through here, all I have to do is sort of follow these lines, and that would give me what that would look like. Alright, so that would kind of look something like that. Obviously this is just a sketch, but notice that you should already know that the original function must have been an x squared. If you integrate this, if you take the antiderivative of that, you get x squared. Alright, so the equation of the original function, because you know how to integrate, it would have been f of x is equal to x squared plus c. Okay. Now if we pick a different point on the graph, for example, like I don't know, 0, -3, what happens to the graph? Well, what happens to the graph is that the graph is going to shift vertically. Which is why we have the plus C. Alright. So since we did the opposite of taking a derivative, this is finding the antiderivative, so that's what we just did. So this is what the slope fields are good for, just to find antiderivatives. And let's go to the back here. I'm going to go through this one pretty fast. It's the same logic. Alright, so we have this derivative is negative x over negative x over y, and it goes through point 2. So they want us to find the solution of that. Okay, so the first thing we should do is just plug in a point here. Notice that if I plug in a 0, 0 here, which is the origin, that's going to give me an undefined slope. Okay, so this is no slope, which also you can say that's a vertical line, so that would be alright with that too. Let's go to 0, 1, for example. So if I pick a point in this graph, which is 0, 1, which is right here, alright, this slope would be 0. And again, remember where I'm getting that from. I'm plugging in this x and this y back into here and here. So we have that the slope is 0, which is a line like that. And because, not exactly because what we did last time, but if I plug in a 0, for example, 0, 2, it doesn't matter what y is. It could be 2, 3, or 4, or 5. All of these are going to be horizontal lines because the denominator would be 0 anywhere on here, okay, because of this function. So if we go, for example, 0, 2, that again, slope is 0. If we go to a slope of 1, we have 1, 1, which is, let's see, that would be right here. So it would give me a slope of negative 1. Again, I'm plugging that back in here. So negative 1 would look like that. Alright, if I pick a point such as 1, negative 1, that's going to give me a positive 1. So 1, let's see, 1, negative 1 is going to give me a line like that. Alright, let's see what else we got. Let's see, anywhere on here that will give me y is equal to 0. So if y is equal to 0, that's going to give me more or less a vertical line. Alright, it's at no slope. So I'm going to kind of write that on here because we know that. Let's see, if we have a 1, 2, we have a slope of negative 1 over 2. So let's see, 1 up 2, we have a slope of 1/2, so it's a little more flat. And just for the sake of time, if you do the same thing to all of these, you would have this sort of graph, or this slope field, I'm sorry. Alright, so if you go on and just kind of fill up that graph, that's what that would look like. Hopefully you can see that well on your paper. Can't really tell if you can or not. Alright, so that's what that would look like. So notice that that has the shape of a circle. The slope field has the shape of a circle. So the original function must have been a circle. Alright, so at point 0, 2, alright, I'm pretty sure this is going to be a circle with the radius 2. And to verify, alright, the equation for a circle, we would have x squared plus y squared is equal to 4. And if you take the derivative of that, I should get back that derivative that I have right here. And if I do, then that's correct. Alright, so that would give me 2x. Notice that this is implicit differentiation here. The derivative of y squared is 2y dy dx. The derivative of a constant is 0. And if you subtract the 2x and then divide by 2y, you would have that, which means that dy dx is x equal to negative x over y. And that's the answer. Okay, so we're good. Let's check out. Let's go to example number 3. Now on this one, they're asking us just to graph this. The derivative of function f is 1, that's actually just a horizontal line across 1. It's no big deal. Now if we're drawing the slope, right, the slope for this, think about it. Now on this one, no matter what I pick, and I'm just going to do a couple of these here. No matter what I pick, the slope is 1, alright, because that's what it says. So it doesn't matter what points I pick on here, 0, 1, 0, 2, whatever it may be, the slope is always going to be 1. So no matter which x or y value, the derivative is going to be equal to 1. Alright, so for the slope field, you're really just going to draw a bunch of little lines that have a slope of 1. You could, make sure they kind of look like they have the same slope. And eventually when you get to your homework, by the way, which I'll be happy to help you with, you're going to find a pattern. There's no need to necessarily do a table every time. You can just sort of do that in your head if you can, if it's easy enough. But a lot of these, you're going to find a pattern which is going to save you some time. Alright, so if it's definitely time consuming, but you only have about 3 of these to make on the homework. So if you got any questions, please let me know. Alright. It's taking me some time. Alright, so that's what that will look like, and it says sketch a particular solution that goes through a point 0, 0. So if it goes through point 0, 0, then that would look like that. And that's it. Alright, it has a slope of 1. So this right here, that's the solution. Alright, again, this is a pretty short lesson. It can be very time consuming, but if you got any questions, make sure and ask me.